Okay, what's your first column?
Time.
10.
Wait, the second column should be total distance or is it net distance index?
Okay, I suggest if you see different progressions, split it up. So give me one for Carol, one for waves. It's easier to sum up that way. Okay, so it's the distance that Carol swam. And there's the waves, okay? Split up progression is always easier. So time 1, Carol swam a distance of 80, yeah?
Yeah.
The waves will be, do a 4 here, okay? Then time 2, it was 1% less, so it's 80 times 0.99. And the waves would be
First cycle, minus 0.05. Like 4 minus 0.05.
Yeah, very good. Okay, then do 3, right? Remember you just up to 3 to see a pattern. So this 80 and 0.99 squared. This is 4 minus
0.05 squared.
Careful.
0.05 minus 0.05. Two times.
Yes, thank you. Okay, don't, like I always tell you guys, like don't simplify this. Keep in raw form so you can see a nicer pattern, yeah. Okay, then it's n here, right?
Yeah.
Okay, n minus 1, 4 minus n minus 1, 0.05. Notice how clean it is if you separate them out, like Carol and then weights. Okay, not very confusing. I have to do it both in one column. Okay, for part 1, find the distance between Carol and the shore after the first 5 minutes.
You take you sum up the distance you swam minus away the wave.
So distance equals to? For Carol's a GP, yes. What would it be? So Sn for GP is A 1 minus Rn over 1 minus R. So A is 80. Common ratio is 0.99, yes?
Yeah.
Number of terms?
And 5
5, yes. Then divided by 1 minus 0.99. Okay. Then minus of your waves. Waves is an AP. So Sn equals to n over 2. You can either do me an A plus L or 2A plus n minus 1D. Whichever you prefer. So 5 over 2.
A plus L.
Can. A plus L. Minus here, yeah. If you do an A plus D, please remember that your D is negative 0.05, okay? Be very careful, ah. Do you want to the nearest, it didn't say, it's gonna go to 368.
372.6.
Yeah, 373. Alright, part 2 is easy. It is now given that the ocean waves became weaker away from the shore until they pushed Carol back towards the shore at 2 meters per minute from the nth minute onwards. Show me the n equals to 41. This is really easy. Now for any Apgp question, ask yourself, okay, am I finding a specific term, which is a UN, or am I finding an SN, okay? Is it a UN or SN?
UN.
Very good. They're using the waves, yeah. So the general form would be,
Wave is AP, right?
yeah, here, right?
It's the A plus n minus 1.
Exactly. We have it there already, okay? So part 2 would just be 4. It's either you put a 4 plus n minus 1 times negative 0.05 or just follow what we have in the table. Is equals to 2. This 1 mark is super worth it. 40, so it's 41.
Like in this case, UN is the one that's 2, right?
I'm sorry? Ah, yes.
UN is 2.
Correct. UN equals to 2. Forty-one, yeah? Shown.
Yeah.
Okay, part 3. Hence, find the time taken for the distance between Carol and the shore to be at least 5 kilometers, giving your answer correct to the nearest minute.
You equate the distance to 5,000.
And then,
Then you find n.
okay. How would you find the distance then?
Uh, can you just take the n term, the n term for what Carol swam minus away the waves, then you just see.
Okay, be careful. Are you looking at sum here or specific term? Distance
Sum.
is a sum, so you're going to find me the sum for Carol and the sum for the waves, yeah?
Yeah, like can you just take like from part 1, then replace it with n?
No, you cannot. Okay, why can't you do that? You're thinking of using this one here, right?
Yeah.
And we say n, right? Okay, why can't you do that?
Isn't it the sum?
It's not, because the waves would stop becoming an AP. The waves are constant after at the 41st minute.
Or use it after the 41 minutes?
Yes, correct. So you got to find me for the first 40 minutes, yes.
First 40.
Yeah, so because essentially what happens is, okay, I'm going to draw a timeline. From time, like minute 1 to the 40 minute, right? Carol will be swimming at GP, the waves doing an AP. Correct? So it's like GP minus 5 by AP.
Yeah.
But from the 41 minute onwards, Carol is still doing the GP, but the waves is a constant now at 2 meters per minute. You see the
Yeah.
difference? So you got to split it up. So you find me for the first 40 minutes, and the entire distance will be 5 kilometers, 5,000 meters. So you find me the distance for the first 40 minutes using the previous equation. Then after that, you find me what's going to happen for the 41 minute onwards.
Okay.
Okay, yeah? Let's find the first 40 minutes first. S40 equals to. So you can replace, it's very easy. I'm going to use the previous equation.
Okay, just replace n with 40, right?
Exactly. Okay, that one follows the progression you did just now.
Okay, what is the minus 0.05?
The common difference is negative, remember? I used the 2a plus n minus 1g. Go to your progression above. Remember the ways got weaker? D here is negative 0.05. Yeah, be very careful on some little things in there. Makes a lot of difference to your answer. 2527.2259. Okay, so remaining distance is 2427.77. Got the same answer as me?
Yeah.
Okay, great. Okay, now, so you're now going to find me the time for the remaining distance, yeah. So essentially, my remaining distance is going to be here. I'm trying to find at what time would I hit 2472.77. Okay, give us a shot. How do you find this? So essentially, it's the same, right? Carol is doing her GP, the ways I'm doing AP.
You equated the equation n by n.
Okay, what equation though? Formulate for me.
Like the Carol stem, the GP will be
Okay,
from n equals 41.
okay. What would the equation be then?
The sum, you take the first term as 41.
Very good. Okay, well done. The A should be 41 now, which is A, then R, n minus 1. Can you follow? These are A, yes? Because I'm starting from the 41
Yeah,
minute.
yeah, yeah.
So U 41. Okay, well done. Then 1 minus R. I'm going to let T be the time from the 41 minute onwards, so it's less confusing. So over 1 minus R. Okay, so this I'm going to put it here. This is U 41. Remember that. Okay, then the ways is easy. What should the ways be?
It's just 2 times
Exactly.
n.
T. This is T. 2T. Okay.
Okay.
And this should be more than equals to 2472.77.
Then use this.
Correct. Now the question said give your answer the nearest minute, which means they want a whole number lah. Okay. If they didn't say that, unfortunately you gotta draw me a graph to find the nearest to find the decimal place answer. But now they want the nearest minute, which means the unknown is gonna be an integer. So press second graph instead.
Okay.
Okay, follow yeah. Okay, be very careful you're finding. Sometimes a common difference, common ratio may not be a whole number, so do not press second graph. Okay, go and key this whole thing in. Just be careful when you key in. Let me just scroll a bit more for this one.
You second graph it, right?
Yeah, only because it's nearest integer. That's the question answer for. Yeah, okay. And t here is the time from the 41st minute onwards, yeah. Which means the total time should be 107. Yes, total time equals to 67 plus 40, so 107. Okay, great. Now part 4, find the greatest distance between Carol and the shore and the time it took for her to reach this distance. Describe what happened to the distance Carol swam per minute after she had reached this greatest distance. Sum to infinity only for like Carol's part, right? But the way is not really infinity, you realize.
The waves are just going to stay constant.
Yeah, but they're still going a distance to it, isn't it? Because it's a AP for the first 40 minutes and a constant for the next like whatever minute is. So sum to infinity only works for Carol though, not for the entire equation. So how do you incorporate your waves? Okay, why don't you find me like uh-huh.
Is it when you the mod of the slam minus away the wave? That's it.
Can also. Yeah, that also works. Okay, if I were you, I'm going to find a total distance that represents Carol and the waves. So total would be the first 40 minutes, which is your 2527.2, right? Then plus Carol swimming, which is the 80 times 0.99 to the power of 40. Then 1 minus 0.99t over 1 minus 0.99. Then minus 2t. Okay, follow? This is for the first 40. This is from the 41 minute onwards. The total distance that represents Carol and the shore. Because for the first 40 minutes, it's fixed, right? At 2527.2. Okay, now essentially I'm forced to find a maximum for this, the greatest distance. So what I'm going to do the easy way is to go to my GC, plot a graph, and find a maximum point. It's easier than solving by hand. Can you follow? Because essentially I'm asked to find a maximum, a greatest distance, right? Which means I'm trying to find a maximum distance. So you can do your method, which is finding that when this, the modulus of this and this, minus it off, is less than or equals to 0, which means Carol is being pushed back, essentially. But it's going to be quite hard to solve by hand. So I'm just going to plot the entire equation here to my GC and find a maximum point from my graph. And that will be the greatest distance. It's easier that way, right? Okay, because it's only like 3 marks. It's not worth all the working. So go to your GC and plot the entire thing in, then find me the maximum point. Please remember to change your winner settings, okay? You try it first.
Wait, the 41 onwards, right?
Yep.
It's a GP, right? No, AP.
No, it's a constant. It's the sum of a constant. Get rid of this. Oh, your 2t is the sum of constant because it's constantly at 2. It doesn't change anymore.
Then the thing before that minus the
Still a GP. Yeah, this is your GP. This is constant. This is sum of a constant. You gotta change your axis, yeah. No, you probably won't see anything. Yes. Okay, now. Okay, you try first. You try first. Okay.
Oh wait, what do you use for the thing? I mean, I can give up, but I think it's too small.
What's your maximum for axis for your what x-axis?
I put it at 1,000.
Can. Your y maximum?
I put it at 5,000.
Oh, can also, can also. Your graph should be quite nice, right? It's like that. Wait, let me draw it here. Something like that.
I got like the opposite.
Opposite. Show me your graph and your equation. That looks strange. Show me your equation. Oh, you can also set your x minimum as -10 and your y minimum as like negative whatever is -10 also can. Because you don't really want to see negative distance here, right?
Yeah.
And negative timing. I think you typed your equation wrongly. Show me your equation. This graph looks strange. It's like a minimum point instead.
The other side is the same. Let's do
2527 to last. Hey, your x should be for 0.99, not the whole thing. It's 1 minus 0.99 power x, not this.
Oh.
Careful.
Now my graph goes up but doesn't come down.
You mean like it keeps increasing?
Yeah.
Your Windows setting is x max is 1000, y max is 8000.
My Y max is 5,000.
Y max, try 8000.
Oh yeah, okay.
Then you can see, right? Okay, find your maximum point.
It will come all the way down, right?
It will come down, it will come down. Okay, what's your max point?
7.53.
Yeah. This is 327.53. There was one distance, yeah, which is the one and the y value there. Okay, what's the distance?
7024.
Yeah, correct. Anyway, they want again to the nearest minute, so it's going to be 328, yes.
Yeah.
Mm-hmm.
Wait,
And
how do you know which axis to be sensitive?
oh, okay, you keyed in your y equals to, right? So y, this is your total distance, then equals to, this is your time distance. So this is t and this is y.
Yeah.
Yeah. Okay, so again, remember the t, right, is for after the 40th minute from the 41st minute. So the total time should be plus 40, yes.
Which is 7024 plus 40.
No, time. Time is 328. Then plus 40. Time is x-axis. This is x and this is y.
Yeah.
Here, so my total time is 368.
Yeah.
And of course, the last part to this question is describe what happened to the distance Carol swam per minute after she had reached this greatest distance. Obviously, she swam below 2 meters per minute. Can you follow, yeah?
Oh, yeah. Okay.
Because the waves will push her back, That means she's no longer swimming further. She's going to be pushed back to the shore. Can,
Yeah.
Okay,